All right, good morning, everyone. Let's get started. So for those of you who just joined, you can start out by going to Canvas and looking under the assignments section. There's a new section in there now called activities. And I want you to open up the document in there that's called Activity 1. I will also share it on my screen. The other thing you can do is start ArcGIS Pro opening up so that you can work along with me today in class on this activity that we'll be doing. So this is activity 1. I'm going to just let you guys take a minute to read through it so that you're familiar with what it's presenting and what we are going to be tasked with accomplishing today, or today and on Tuesday if it runs over. All right, so hopefully you've all had a chance to read through that. And so in summary, what we are going to be looking at today is one of 3 species of Colorado chipmunk, Neotamius quadrivittatus, which is the Latin name for Colorado chipmunk, and that's one of the most common species. And we're going to be looking at the quality of habitat that's available for it in City Park. Who can summarize for us what constitutes good quality habitat for this species based on what's written on the sheet here?
1.25 acres of continuous tree cover.
Correct. So that 1.25 acres of continuous tree cover is considered what we're calling here the ideal habitat, right? So that's the area where the chipmunk would prefer to be all of the time if it had the option. That said, it is willing to skitter from one patch to another across short distances of open area, so nothing greater than 20 feet. So if we take together all of the ideal habitats, so these patches of continuous tree cover, plus 20-foot breaks in between them, then altogether that constitutes the effective habitat, right? Because that's the total area that this chipmunk is willing to explore and move through in terms of accessing everything it needs for its life cycle. So finding food, finding mates, nesting, raising young, and so forth, right? So what we're going to be looking at today is what quality the habitat is and how much habitat there is in City Park in Denver. And I've posed at the bottom 6 questions that we would like to try to answer with this project. So the first is, what are the minimum and maximum patch sizes of ideal N. quadrivitatus habitat? What is the mean patch size, so the average patch size of ideal N. quadrivitatus habitat? How many patches of ideal habitat meet or exceed the minimum viable patch size, right? So that's just looking at the ideal patches without, or the ideal habitat without any of the breaks in between, not looking at the effective habitat and figuring out how many of those are big enough to be viable to support a chipmunk population. Then we're going to be looking at the percentage of the overall landscape that is ideal habitat, the percentage of the overall landscape that is effective habitat, so the area through which it'll travel, that includes those 20-foot open spaces between patches, 20-foot maximum, I should say. Anything less than that, it will also obviously move through. And then finally, what percentage of the overall landscape is effective habitat that meets or exceeds the minimum viable patch size for N. quadrivitatus? So we're going to be figuring out how we can use GIS and use map data to answer all these questions and to visualize what the habitat for this particular species looks like. So with that in mind, and this is something that you should be working along with me, because you actually do need to turn something in when we're done with this. So you'll be turning in your answers to these questions above, as well as a map that shows both the ideal and the effective habitats for N. quadrivitatus. And you'll be submitting that as a PDF to Canvas under Activity 1. All right.
This is all on GIS, right?
This is entirely on GIS. Yes, all of these answers will be through GIS. All right, so knowing all of that, what would you do as a first step? Does somebody want to volunteer?
Find data.
Find data, yes. What kind of data specifically?
Probably tree cover data, planting data.
Exactly. So where would you look for that data?
Denver Metro's website, maybe.
Yep. Denver, it's another term for it, where they keep all of the GIS data.
Open data.
Yes, Denver Open Data. So let's open up a web page. I'll bring this over here. And let's browse to Denver Open Data. Here's the Denver Open Data catalog. I know we want some kind of tree cover, so I'm just going to type tree up here and see what comes up. And lo and behold, there's Tree Canopy 2006, there's Tree Canopy 2014, there's some other ones from 2013. So I think Tree Canopy 2014, oh wait, there's a second page. Let's see what that has. Tree inventory, which may or may not be as helpful, because really the tree canopy is the thing that we're interested in, not the individual trees. So that is probably going to be our most useful data set. So I'm going to download, Tree Canopy 2014. So I'll click on that. And which version of the data do we want to download?
The zip shape file.
The zip shape file, correct. So I'll click download next to the zip shape file. And it'll ask where I want to save it. I have a folder set up on my C drive for GIS data. So I'll go to that. I'll go into my Denver folder and I will just save Tree Canopy 2014 into that folder. And you can see in the lower left here, it's downloading. That'll just take a minute. There we go. All right. So I'm going to close this web page now. And now I'm going to browse to that folder where I downloaded the data, right? Because I need to do something with it. I can't just use it the way it is that we downloaded it. So let's go to GIS data, Denver. Okay, there's my zipped tree canopy 2014. What do I need to do with this so that I can use it in GIS?
Extract.
Extract. So let's right click on that. And I'm going to choose extract all. And the dialog that comes up is going to default to create a new folder for it. That's fine. So I will click extract. And we'll give that a couple seconds to finish. All right, so there's all of our tree canopy shapefile. And again, we need to keep all of these files, right? Not just the SHP, we need all of them for it to work properly in GIS. So now, do I need this zip file anymore? Nope, let's delete it. All right, so that's gone. I have a folder called Tree Canopy 2014. So now we can go into ArcGIS now that we have our data prepared. And so the first thing I want to do here is I want to start a new project. Which type of project do I want to do? What button do I want to click? Sorry, say that again, Bryce.
Map.
Yes, I want to click on a new blank map template. So let's click on that. It's asking what I want to call it. And I'm going to go in here and I will call this, let's call it Chipmunk City Park. But you can call it whatever you want. This is what I'm calling it, Chipmunk City Park. I want to make sure that this box is checked to create a new folder for the project. I'll click OK. And this is going to just take a few seconds to set up the new project and create the geodatabase. All right, so here we are with our new map. And then over on the right side in our catalog pane, if we open up databases, we can see there's my Chipmunk City Park geodatabase. And now I want to be able to bring the data in, right? So how do I get to where I saved my shapefile? What's the next step here?
Don't you add a folder connection?
That is correct. So under folders, I'm going to right click on folder. I'll choose add folder connection. And it opens up a window asking where I want to add the folder connection. So I'll just go to C and then GIS data, and I'll click OK. That gives me access to everything inside that GIS data folder. So now if I open that up, I see Denver, I can open that up. And then Tree Canopy 2014, there's my shapefile. Awesome. Can I just use the shapefile the way it is, or do I need to do something with it? I know that's a very leading question.
You should just be able to use it, drag it over to the left side, right?
You can, but you shouldn't. Because there are a lot of things in ArcGIS that simply won't work right if you're using a raw shapefile. So we need to format it so that it can be used in ArcGIS. How do we do that?
Are you going to create a feature class?
Correct. So I'm going to bring that. I need to add it to my geodatabase as a feature class. So if I right click on my geodatabase, I'll go to import and then feature class. And it wants to know what the input features are. So I'll click the folder here. And I'm going to browse to my folder connection. So GIS data, Denver, Tree Canopy 2014. That's the shapefile I want. So I'll click OK. And then it's adding it to the correct geodatabase, and now it wants an output name. So I can call this, let's call this tree space cover. That's a good name, right? Is that a good name?
Can't you not have spaces?
That's correct. This is a terrible name. And in fact, it won't let me execute the tool because of the space. If I try to hit run here, it just gives me a little X next to the output name. So let's get rid of that space. So that's like that. There we go, tree cover. Now, if I hit run, it will add that shapefile, and you can see it, see the progress bar down here in the lower right. That'll just take a minute. So we will let that get formatted and added to the geodatabase. And this will also automatically add the data to our map once it's done running. And you can see there's a lot of tree cover data there. All right. So now that we have our tree cover data in the map, what is the next step? We're still in the setup process. We're not even getting to the analysis yet. What's the next sort of setup step we need to go through?
Coordinate system.
Sorry, say that again, Bryce.
Is it the coordinate system?
Yes, correct. We have to set up the coordinate system. So I can do that by right-clicking on map over here in my contents pane. And then I'll go to properties, click on coordinate systems in the window that opens up. And what coordinate system do I want to use for a project in Denver?
It's like,
Colorado Central.
Colorado Central in the state plane coordinate system. So if I scroll down, that's going to be under projected coordinate system. So I will open that up, scroll down again until we find state plane, open that up, and then I'm going to go to NAD, North American Datum, 1983, 2011 update, US feet, right? This one right here. So I'll hit the triangle next to that. And now we're going to scroll through and look for Colorado Central. Here's Colorado Central, there it is. So state plane, Colorado Central, US feet. So now I can click OK. And the map will reformat to have the correct coordinate system.
Where was that under again?
So if you right click on map, you go to properties, and then you click coordinate systems on the left. And then on the right side, you want to go under projected coordinate systems. And then you want to go to state plane. Whoops. There it is. You want to go to state plane. And then under state plane, you want to go to NAD 1983, 2011 US feet, which is the fourth one down. And then in that has all of the coordinate systems in there for the 2011 update. You want to find the one that's called Colorado Central. They're just in alphabetical order by state.
Thanks.
Yep. All right, so now we have the correct coordinate system in here. So what's the next thing that somebody, and I want you guys to kind of be, I don't want to just sort of tell you step by step what to do. I want all of us as a group to sort of puzzle through what we need to do to answer some of these questions that are posed to us in the activity.
I'm sorry, Scott.
Yep.
I'm having trouble getting my feature class to feature class work.
Okay, was it say, what, do you get an error message or?
No, it just didn't. When the second feature class popped up, it just didn't put any data on the map.
Okay, did your output name have a space in it? Because it cannot have spaces and it can't start with a number either.
No, it didn't.
Okay. If so it finished the process and just didn't add it to the map?
Yeah.
Okay, so what you can try, let's close the geoprocessing window here. And I'm going to look under my geodatabase here, and I have a tree cover layer. If you don't see anything under there, you can right click on your geodatabase and choose refresh. And then do you see your tree cover layer?
Wait, hold up. How do you get to the, oh, you're going to catalog, okay.
Yep.
It's in there, it just doesn't have anything.
So if you drag that layer, is that layer showing up in your contents pane?
I have my GIS set up a little different than that. I don't know why.
Do you have your contents pane? Can you see it?
Yeah. Oh yeah. So I have it under Denver. I have it under my file name geodatabase, but it's not on the map.
Okay, so you can just grab that tree cover layer and click and drag on it and just drop it on the map. And that should do the trick.
Okay.
And so while you're getting caught up, does anybody else want to suggest what we might want to do next now that we've got our tree canopy data?
I had a quick question.
Sure, Bryce.
I was just curious, like, can you download shape files and then they're on like a different, they made them on a different coordinate system than the one that you're gonna work on, so do you have to change the shapefile coordinate system ever, or is that just something that if you put it in your geodatabase, it's just gonna be the same coordinate system that you are gonna pick in the beginning?
So that is an excellent question. So actually there was an option. If I go into Chipmunk City Park, if I right click and then I go to import feature class, you'll notice that there's the parameters, which is what we're used to seeing, but there's also a tab called environments. So if I want to change, because I can guarantee almost all of the shapefiles are saved in WGS 1984, which we don't want to use. So up here under output coordinates, you can say, I want to change this to a different coordinate system when I bring it into my geodatabase. Right, and so you can click on this little globe over here and then browse to projected and state plane and so forth. And then that'll convert it into that correct coordinate system in the geodatabase. As long as your map is using the correct geodatabase, it really doesn't matter what it's saved as, because the map is converting all of the geometry to the correct coordinate system.
Okay, gotcha.
Yeah. So, but that is a good question, because some of the things we'll be doing a little bit later, we will be going in and making sure that we have that set to the state plane coordinate system when we execute some of the tools that we'll be working with.
Okay, sweet. Thank you.
All right. So we've got our tree data in here. So does anyone want to propose what we might want to do next, just to get our bearings at least? Right?
I would take the outline off and make it green, like the data itself.
That is an excellent suggestion, because that gray outline just makes it very muddy and hard to see what's in there exactly. So I'm going to click on the symbol for tree cover, and over here on the symbology pane, I'll click on properties. And then let's get rid of the outline color. So I'll change that to no color. And then I want this to show up a little bit better. It's such a faint green that it's going to be hard to see right now. So I'll make this a dark green and click apply. And then that should show up a lot better on the map. And now I can close that symbology pane. And you can see now it's a little bit easier to see exactly where the tree cover is and the density of it. All right. What do we want to do now? We have all these trees for the city of Denver. What's our next step, do you think?
Find just the city park data.
Find just the city park data, yeah. So we want to, first, let's find city park, right? So if you're not familiar with where city park is, you can search for it, I believe. I've actually never tried just searching for a location on the map. Let's see. Somewhere, oh, here we go, locate. And then over here on the right, I'm just gonna give it a shot. Let's try city park. And then it brings up some options down here. So there's city park at 1800 York Street in Denver. That sounds pretty good. So there's also just city park in Denver. Here, I'll try that one. I'll click on that. And boom, look at that. It zoomed us in to city park. And in fact, if you're not sure if you're in the right place, you can always just turn off your tree cover layer. And we can see, sure enough, here's city park. There's the Denver, whoops, there's the Denver Zoo. Here's the Science Museum. Right, so here we are. So let's turn our tree cover back on. And so we've got trees in Denver in City Park, but we've also got trees all over the city, right? So what do we want to do here?
Maybe clip the data to our boundary of City Park.
Correct, because we just want to look at the data that's in City Park. So the easiest way to do that is
You can make
to,
polygon.
Sorry, what was that?
You can make like a polygon selection, like feature class type thing, right?
You can do a polygon selection, but actually we're going to do an even easier way.
Oh, sweet.
So what I'm going to do is I'm going to zoom in so that City Park basically fills my screen. And I can fine tune this. So basically what I want to do is I want to zoom in enough so that I'm just seeing City Park on the map. So I'll zoom in as far as I can. And then in the lower left here, I'll just fine tune my scale. Right now it's at 1 to 2902. Let's try 1 to 2800. That zooms in a little bit more. I think that's pretty good. You know, if we get a few trees that are just outside City Park, that's fine for the purposes of this exercise. Now I also want the east to west direction to be clipped to just City Park. So I'm going to move this over. So we have just a little bit hanging out of City Park on the left side here on York Street. And then I don't want to see all this data on the right side. So in order to change that, I'm just going to drag the, here, let's close our locate panel so that we just see the catalog. I'm just going to drag that catalog over so that it comes over to the edge of the street, and then I'll recenter my map. Right, and so your map should look something like this so that you're just seeing the area in and immediately adjacent to City Park. Right, does everyone have that? Awesome. So once we have that, there's an option in ArcGIS to basically take just the data that we see on the screen and to create a new feature class from it, right? So the way we're going to do that is that I'm going to right click on tree cover on my contents pane, and I'll go down to data and then export features. I'll give you guys a minute to find that. I'll click on export features. And so it says our input feature is tree cover. That's correct. Output location is Chipmunk City Park Geodatabase. The output name, we can call this whatever we want. I'm actually going to call it ideal habitat, right? Because anything that's full tree cover is basically ideal habitat. And so all of this tree cover that we're seeing constitutes that ideal habitat. We don't know yet how big it is, whether any of these patches are large enough to support a chipmunk population, but at least we know that we have the correct kind of habitat here. Now, before we hit OK, if we just hit OK, it's just going to make a copy of the entire city of tree cover. So we need to tell it that we want to limit the area to just what we're seeing on the screen. And to do that, I'm going to click on the Environments tab up here. And we're going to do two things. The first thing is under Output Coordinate System. We'll drop that down, choose Current Map. And so that means that this new feature class it's creating is already going to have the state plane coordinate system baked into it. So we don't need to, if we start a new map with this data, we wouldn't have to set that coordinate system again because it's already sort of baked into the data. The other thing we need to do is that down here where it says processing extent, default just means take all of the data and move it to a new feature class. If I drop that down, one of the options is current display extent. So I want to click on current display extent, and it'll put in some coordinates that are automatically generated based on what I'm seeing on my screen right now. So this is going to limit the data to exactly what I see on my screen. So we'll get all of the trees in City Park and a little bit of, a few sort of patches of trees outside City Park. And that's fine for what we're doing if it's not exact right up to the tree. All right, so once we have all that set, so first of all, any questions about that setup before I export this?
Yeah, what'd you go to get to that?
So you right click on tree cover on your contents pane, and then you go to data and then export features. And then you just have the parameters tab and the environments tab at the top. Any other questions? All right. So I'm going to click OK once I have everything set up. And this is, it says feature class to feature class. So it's basically duplicating the data to a new layer called ideal habitat, right? So it looks like on my map, nothing's really changed. But if I turn off my tree cover layer and then I zoom out a little bit, we'll see that after this regenerates, we'll see that I just have tree cover for that area immediately around and in City Park. Right, so we've clipped the data now to the area that we're interested in studying. Good, right? Makes a lot of sense.
No.
No, doesn't make a lot of sense.
No, sorry, my GIS just quit.
Okay, so I think, Casey, what you might want to do is just kind of follow along, just by watching what I'm doing, and then maybe after class, watch the recording and go back through the steps to try to recreate it.
Yeah, I'll try to catch up, but I'll pay attention.
Okay. All right, so now we have our data clipped to ideal habitat. And in fact, we don't even need the citywide tree cover anymore because that's just extra data that was a source for our actual area of interest. So I'm going to remove that from our map. So I'll right click on tree cover and I'll click on remove.
I was gonna say if you haven't done already, save.
Mm-hmm. Yes, that is an excellent point. So anytime you make any big moves in GIS, it's liable to, as Casey unfortunately experienced, it can crash sometimes. So just to make sure we're not going to lose anything, we want to save our project. So that's at the very top of the screen here. The third button over is save. So I will just click that and that will save what we've done so far so that if anything unfortunate does happen, we can get right back to where we are.
The worst part is it was while I was saving it that it crashed.
Oh, yikes. That's the worst time for it to crash. All right. Okay, so now we've got our data clip. So let's go back to the activity sheet for a second. Right, and so let's see, we've got on here some for N. quadrivitatus, the ideal habitat is tree cover, but it can also have an effective habitat, right? So we're going to want to figure out at some point what the effective habitat is. But before we get to that, let's see if we can answer any of the questions down at the bottom here. So first question, what are the minimum and maximum patch sizes of ideal N. quadrivitatus habitat, right? And so how might we do that? Are we able to find that information based on what we have already? Or what's a good place to start looking at least?
Find what? The mean patch size?
The largest patch size and the smallest patch size in City Park.
You could probably go to the attribute table and then sort it out like largest to smallest.
Correct. So let's go into ideal habitat. I'll right click on that and I will choose attribute table. And so down here, I'm just going to drag this up a little bit so that we can see it better. So in here, it's got shape length, it's got shape area. And what sort of units do you suppose shape area is in?
Probably square feet, right?
Probably square feet, but we're not absolutely certain, right? Because we don't know if this data, and actually a good way to find out, let's go to the original tree cover because that one had a different coordinate system in it. So I'm going to bring that back into our map. And I'm going to open up the attribute table for the original tree cover layer, see if that has shape area in it as well. It does. It has shape area, but they're all 0. Look at that. So they're all 0. So when we limited the data and then exported it to a new feature class, it filled in that information for us. So hopefully that's all in square feet. What should we do? If we want to be absolutely certain though, we can actually calculate the square feet for each one of these patches just to make sure that we definitely have the right information that we're working with. So in order to do that, I'm going to create a new field. So I'll click on add field.
Hey, Scott.
Yes.
For some reason, my attribute table doesn't have shape length or shape area. It just goes to unique ID.
Okay, it might just be hidden then, in which case it's also a good idea to add our own field that's going to have that area data in it. So I clicked on add field. It opened up this window up here on top that says fields ideal habitat. And so now I can create a new field. So where it says field here, if it ever reacts. There we go. So I can highlight that and I need to give this field a name. So let's call this patch area. And the same rules apply as for when you're creating feature classes. You can't have spaces and it can't start with a number. So I'll call that patch area and I'll hit enter. So we have a new field called patch area. If you remember last time, actually, I don't know if I talked to you guys about data types, but you can have text data, you can have raster data, you can have short, long, float, or double. Those are all different types of numeric data. Almost always when you're dealing with numeric data, you just want to choose double because that's the most accurate form of numeric data. And then we can set the format of that numeric data. So over here where it says number format, I'm going to click in that window. And there's a little ... I'll click on that. And we want to change the category to numeric. And that opens up a window that lets me set some parameters here. So first of all, it's going to go to 6 decimal places. Do you think we need to know 6 decimal places of accuracy for the patch size? Probably not. We're going to be dealing with thousands of square feet. If it's like, 20,000.06, it's not going to matter. So I'm going to change my decimal places to 0. I just want it to the closest square foot. That'll be close enough. Down here at the bottom part, show 1,000 separators. Sure, that just makes it easier to read. That just puts a comma at the 1,000 separators. And then suffix will be really useful. So I want this to be square feet. So I'm going to put in here a space and then SF. In fact, actually, that might be an option in the drop down as well. Let's see, there's SQFT, but you can make it whatever you want. So I just put in a space so that it doesn't just say number SF. There'll be a little space in there so it's easier to read. And then SF for square feet. Right, so once I have all of that set up, I can click OK. And so your fields should look like this, where it says patch area. It's set to a double, and then the numeric settings are 0 decimal places, show 1,000 separators, and then SF as the suffix. Right, so once I have all of that set up, I can close this field. I can click the save button up here if I want to, or if I just click the close button, it'll prompt me to save those changes. So I'll just say yes. And we'll give that a second. And now you can see we have a new field here called patch area. It's all null because we haven't actually added any data to that field yet. But at least we have that field set up. So now we want to calculate the size of each one of these patches in that patch area field. And there's a tool to do that. So if I right click on patch area, one of the options that comes up is calculate geometry. So that lets me calculate specific geometric features about each of the patches. So I'll click on calculate geometry. And we'll give this a minute. All right, so first thing we want to do is make sure it's using the correct coordinate system to calculate this, because coordinate system is everything when it comes to accuracy in GIS. So we want to make sure it's using the correct coordinate system. So I can just drop down this menu, and if I choose current map, it'll set it to the coordinate system of the current map, which is State Plane, Colorado Central. Perfect. Okay, now I can tell it what it is I actually want to calculate. So next to patch area under target field, it says property. So let's drop that down. And what I want to calculate is the area. So I'm going to click on area. By the way, you'll notice that there's area and there's area geodesic. Area geodesic is like the most accurate way that you can calculate area, because it actually, in addition to just taking the planar area into account, it's also thinking about the curvature of the earth and the topography and all that kind of stuff. It's super accurate, but it's also super, super, super slow. So I almost never use that option unless I'm working in an area that has a ton of topography to it. Like we're talking, up in the Rocky Mountains. So City Park is relatively flat. So I can just choose the planar area and that'll be good enough for this project. And then now we see there's a section that says area unit. So I'll drop that down and I want to choose square feet United States. Right, so what this is going to do is for every one of these objects, so each one of these individual patches here is an object, and for each object, it's going to calculate the patch area in square feet. So once I have this all set up, and again, coordinate system, super important. If you have the wrong coordinate system, all of your patch areas will be wrong, and nothing that you do after this is going to be correct. So I have this all set up. I will click OK. And so here we have our patch area, and you can see it's reporting it with that little SF square feet, so it makes it nice and easy to read. And sure enough, the shape areas, if we look at them, they match up with the square feet of the patch area. So it was calculating it correctly, but it's always nice to just kind of recalculate it, making sure that you're using the correct coordinate system to be absolutely certain that all of your data has the correct measurements in it. All right,
Hey, Scott.
so yes.
My numbers aren't the same as yours.
Okay, you're having all kinds of issues. So is your map set up with the state plane coordinate system?
Yes.
All right. And
So also
go ahead.
with that, because if you have like a different size of area that you're zoomed in on, it will have different number of patches.
Oh yeah, absolutely.
So like the numbers that are on Scott's screen won't be necessarily the ones that are your screen. So patch number 1 won't be your patch number 1, most likely.
Well, I think it is.
Okay. Do you want to share your screen really quick, Casey, so we can see what's going on?
I'm not using the same computer.
Oh, okay.
Yeah.
Yeah, I mean, if you just, as long as you have coordinate system set, and then, you right click on that field, calculate geometry, and you make sure that the property is set to area and that the area unit is set to square feet. And then again, the really important part, coordinate system, is set to the state plane coordinate system. Then you should get accurate results here. So what's different about your numbers? Are they?
For that first field, it's 15,407.
Yeah, so that's fine, because it's probably your area that you clipped for your trees is probably just a little bit different from mine. And so when you clipped out that data, and you're using the clipped city park data, right? Not the trees for the entire city.
Yes.
Yeah. So that just depends on what your specific area was. So I wouldn't stress about that too much. Because if you clipped a slightly different area than I did, then you're going to have different patches of trees in there, and your numbers won't be exactly the same as mine in this order.
Well, my first polygon has all the same numbers except for patch area. That's why I'm concerned.
Oh, really? So like
Yeah.
shape length and shape area are the same as mine?
Yes.
That is concerning. And then what is it reporting for patch area?
15,407.
Interesting.
And it doesn't have square feet. It doesn't have square feet at the end of it. But I did all the same things that you have on that calculate geometry screen.
Interesting. And you're certain that you're in the Colorado Central Coordinate System?
Yes.
I don't know. Tell you what, we can have a little session, a little Zoom session outside of class time, and we can try to kind of figure out where you can share your screen, and we can figure out what's going on. But
cool. To keep wasting time, it's all good.
No, that's okay. All right, so we've got our patch areas here. Oh yeah,
Hello,
yeah.
Scott, can you? I'm sorry. Just can you redo the geometry calculation again, just really quick?
Sure. So have you
you.
already created your patch area field?
Yeah.
Okay. So you just right click at the top of it, and then you go to this button that says calculate geometry.
Yeah.
And then in calculate geometry, first thing you want to do is make sure the coordinate system is set. So I'll drop that down. I'll choose current map, and it should change it to state plane Colorado Central feet US. Okay. And then next to patch area under property, you want to choose area, because we want to find the area of each patch. And then under area unit, I'm going to choose square feet United States.
Right.
And once I have all of that chosen, I just click OK, and it'll take a minute or so, but then it just calculates all those areas. Good?
Okay, thank you.
Yep. All right, so there are a couple of things that we can do to explore some of the information about our patch areas here. The first one we can do is if we right click on patch area, at the very top, there are options to sort ascending or sort descending. So that's kind of a good way to find out quickly what are our largest and smallest patch sizes, right? So if we sort ascending, it's going to sort on this column from smallest to largest. So if I do sort ascending, we can see the smallest patch area is 142 square feet, right? So we already have one of the answers to one of the questions on the sheet, right? So what are the minimum and maximum patch sizes? We have a minimum patch size of 142 square feet. Again, yours might be slightly different depending on what area you clipped out for your tree cover, but it should be pretty close. Now, let's find the maximum patch area. So we can do the same thing again. I'll right click. Instead of sorting ascending, we'll sort descending. So that's going to go from largest to smallest. And we see that our largest patch size is 318,636 square feet. Does anyone have one that's like significantly different than that? Doesn't sound like it.
You know, I do.
Casey, I know all your stuff's going to be wrong. We'll deal with it after class.
Yep.
Does anyone else have a number that's significantly different? All right, awesome. So we've got our answers already for the smallest patch size and the largest patch size. Right, so let's go back to that activity sheet. So minimum and maximum patch sizes are that 142 or 143, whatever it was, and the 318,636 square feet. That's a minimum and maximum patch size, right? Next, it's asking us, what's the mean patch size? Right, so now we need to find what is the average patch size. So how can we do that? So one way we can do that is we can go through all of these objects here and we can manually add up all the patch areas and divide by the total number of patches. Man, that would take forever, wouldn't it? No, that is not a good way to do it. Instead, we can right click on patch area and there's a button a little more than midway down that's called statistics. So let's click on statistics. And that's going to give us just what it sounds like, statistics about all of the data in that particular field. Right, and it even shows us the distribution of the patch areas, right, in a little graph at the bottom. So I'll make that a little bit bigger. We can see the vast majority of patches are between 142 and 10,000 square feet. And then you have way less there between 10,000 and 20,000, even fewer between 20 and 30,000. And then you have like very, very small numbers. You can barely see it, but this bottom axis is black. So anywhere you see kind of this light blue, it means there's like 1 or 2 patches. So we have like 2 patches if we hover that are 30 to 40,000 square feet. Over here, between 70 and 80,000 square feet, we have 1 patch, and all the way at the end here, 1 patch that's between 308,000 and 318,000 square feet.
Scott, how did you get that again? I missed what you said.
Yeah, so on my attribute table for the patch area column, I just right clicked on it and I chose statistics.
Gotcha, thank you.
Yep. And then the other nice thing about this is that over on the right side here, we have other statistics it can show us. So it can show us the mean patch size. And in fact, if I check that box, that's just showing up as a blue line to show us where the mean patch size is. So the mean patch size is over here, way to the left, right? And it shows up in here that the mean patch size is 2,491.4111 square feet. It'll also show us the median, the standard deviation, the count. That's pretty cool. That shows us the total number of patches. So that is some good information to have. It shows the minimum and maximum. So we could have gotten those numbers without sorting the data just by opening up statistics. And then skewness and kurtosis. I don't even know what those are, so I'm going to just skip over those. Right, but we have our mean here, so that's answering another question, right? So roughly 2,500 square feet is our mean patch size. Does anyone have any questions about the statistics so far? All right, so let's go back to the sheet here. So we have the mean patch size of ideal habitat is 2,500 square feet. Is that, so can the average patch in City Park support a population of N quadrivitatus? No, it cannot. How do we know that?
You said the minimum was 1.25 acres.
Correct. How many square feet is 1.25 acres? Probably don't know off the top of your head. I don't either. So usually I just like to open a new Google page. Oops. Bring that over onto my screen. And if we just type in 1.25 acres in SF for square feet, Google will be helpful and tell us that's 54,450. Right? So you might want to write that number down somewhere so that you don't have to keep looking it up. But 54,450, that is our minimum patch size in order to have a viable population, self-contained population of N quadrivitatus. Right? So the average patch is way too small by many orders of magnitude. So, but at least we know we were able to answer that question about what is a mean patch size. Next question, how many patches of ideal habitat meet or exceed the minimum viable patch size? All right, so here's where we want to figure out how many of these patches are at or above that 54, what was it, 54,450? I think it was, yeah, 54,450. So there are a couple of ways we can do this. One way is that, again, here, let's close this statistics window. If I just sort, I can just visually look down the list here and see where's 54,450. It's just going to be just above that one. So visually, I can just see that there are only 1, 2, 3, 4 patches that meet that criteria, right? The other way that I could do this is that I can go up here to select by attributes. So if I click my select by attributes button, and here, let's clear my selection first. Right, so it wants to know what we're looking at. We're looking at ideal habitat, and then it wants a new selection, and we need to build an expression to tell it how we're going to find the patches that we want. So if I click new expression, it says, I don't want object ID, right? If I drop that down, it shows all the fields. I want patch area. So I want to know which objects have a patch area that is not equal to, but that is greater than or equal to 54,450 square feet. Does that make sense? So this is just a way of selecting objects based on their attributes. If I just wanted to find something, all of the patches that were at least 1 acre, that's 42, was it? 48 something, I forget. Does anyone know off the top of their head number of square feet in 1 acre?
43,000.
580?
See, 43,560.
43,560. I knew it was somewhere around there. So we could do 43,560. If I hit apply, it'll show me all the patches. In that case, it's 1, 2, 3, 4, 5 patches. And also you notice down at the lower left of the attribute table, it tells you how many are selected. So 5 are selected, but I don't want that. I want 1.25 acres. So I'll do my 54,450 and I'll hit apply. And down here it tells us there are only 4 patches meeting that criteria. And in fact, right now they're selected, they're all highlighted, right? So there's 1, 2, 3, maybe that's a 4th patch. That's what it looks like. That's a separate patch from this one, right? So that's not a whole lot of patches that can support a good population of Colorado chipmunk. But we got the answer to our question on the activity sheet, right? So we have minimum, maximum patch size. We have the mean patch size. We have the number of patches that meet or exceed the minimum viable patch size. All right. Next thing we want to know, what percentage of the landscape is ideal habitat for N. quadrivittatus? So that means what percentage of the total area that we're working with is ideal habitat, right? So we already know what the total, or we can find out easily what the total patch area is for all these patches, right? That was one of the things that was included in the statistics. So if I right click on patch area and I open up statistics again, so you'll see here, whoops, let's close that little window. So over on the right side here, we have sum, right? So sum is the grand total if we take all these patches and we add them up together. And by the way, when you do statistics, you want to be absolutely certain. I would, just to be safe, deselect anything that's selected, just to make sure that your statistics are not just showing statistics for the selected patches, right? So again, our median about 2,500 square feet. And then we have our sum. So we have, how much is this? 4,120,793 square feet. So that's the grand total of all the patches that we have in here. But we want to know what percentage of the overall landscape is suitable habitat. So how would we do that?
Add up those 4 ideal patches and then use it for a percentage calculation?
No, we're actually going to be doing something similar to that a little bit later. But we have another piece of information that we're missing that we need in order to calculate what percentage of the overall landscape is made up essentially of tree canopy. What's the missing piece of information?
Would it be the total area for the site?
Yes, the total area for the site. So I can measure that using the measure tool up here on my map toolbar. So I'll click the down arrow under measure, and I want to click on measure area. And here it's asking what I'm measuring. So it's planar. Under imperial, I'm going to go down here and choose square feet because we want apples to apples, right? If we're doing a percentage, we can't have the tree canopy in square feet and the park area in acres. We need them both in square feet. So I'm going to set that to planar and square feet. And now I can basically just draw a polygon around the park. I'm going to go a little bit outside the park since my tree canopy goes a little bit outside the park. I just kind of want to capture roughly the area of tree canopy. It doesn't have to be exact. Just needs to be close enough here. All right, and then once we get close to the end, we have 2 ways that we can finish this polygon. One way is to just choose a point and double click on it, and that'll finish the polygon. Or you can right click and choose, oh, interesting, it's not an option here. Finish, I guess it's just when you're drawing actual polygons that's an option. So instead of that, we will just double click to finish our polygon. So I'll go somewhere along here, double click, right? And now it's finished drawing that polygon, and we can see that our area, so up here at the top is what we're interested in. The total area, the sum, is 16,574,924-ish square feet. So I have a piece of paper here. Let me grab a pen. because we're going to want to write this down because I am not going to remember those numbers. So again, I'm just going to make a note to myself here that park area equals 16 million. Oops, 574,000. And we can round to the nearest foot, so 925. So that's our park area. And we know that the sum for our total patches of all the patches is 4,120,794 if you round to the nearest foot. So I'll make a note of that. So we'll say ideal hab equals 4 million.
And those will vary, right? Just based on how we clipped our data.
Correct. And that's part of the reason why you're not just turning in your answers, but also turning in your map so that I can see the area that you clipped and understand that it's, you know, that your numbers are going to be more or less accurate based on that area. All right, so how do we calculate the percentage now that we have those two numbers? Anyone?
Just put the 4 million over the total and multiply by 100.
Correct. So we're just going to divide. So we're going to do 4,120,794 divided by 16,574. I can tell just by looking at these numbers, it's going to be about 25%. But let me open up my calculator and see what it actually comes out to so that I'm more accurate. All right, so I'm doing 4,120,794 divided by 16,574,925. I was very close, right? So it's 0.248, so it's 24.9%. So about 25%. So we've got our answer to the next question. Right, so what percentage of the landscape is ideal habitat for N. quadrivittatus? And the answer is about 25% of the park provides ideal habitat. Now, we've already seen that just because it's ideal habitat doesn't mean that it meets the minimum area requirement. So not all of it is going to be great to support a population, but at least we know the total percentage. Next thing we want is the percentage of landscape that has effective habitat for N. quadrivittatus. Right, so let's take a look at that.
Sorry, so for number 4, are we all gonna have different percentages on that?
Yes, you will all have different percentages, but they should all be, they shouldn't be wildly different from 25%. Like I'd say, you know, if it's like 28% or 23%, then you probably did it right. If you're getting like 92%, then something's wrong.
Okay, I got 7.
7%? Yeah, that's definitely wrong.
37.
Oh, 37? That seems...
My map size, like I accidentally did like I thought there was like a top half to the park, I guess.
Oh, you captured the golf course in there?
Golf course, yeah.
Yes, so that's fine. If you captured the golf course, that's fine. Just make sure that when you submit this, you include the map of the entire area with all the tree cover that you looked at so that I know what area you're looking at. Yeah, in that case, then it probably is higher.
Oh, same with me.
Yeah, so that's just going to vary based on what area you clipped out for your tree cover.
Oh, and also, did you get like 4 million? You said one of them.
I did
which one is
for mine? So that was 4 million was the average, or sorry, not the average. That was the total of tree canopy in the park was about 4 million square feet.
Is it like a segment? The title of it. Can you show me the
oh, where I found that
the
number?
major area?
Yep. So I found that number by, so again, in ideal habitat, I went to patch area in my attribute table and then right click and choose statistics.
Oh, yeah.
And over on the right side where it says sum,
Yeah.
that is,
Oh, yeah. Okay.
yeah, that's the
Uh-huh.
number that I use. So that's that 4,120,000. That's where I got that from.
Right. Okay. Thank you.
Yep, because that's just adding up all of the trees and telling me what the grand total area is of all of the tree cover. All right, so now if we go back to the assignment sheet here, right? So now we want to look at the effective habitat. So we know that these chipmunks are willing to run 20 feet across open space to get to another patch, right? So we need to figure out how we can calculate the effective habitat based on the ideal habitat tree canopy that we already have. So one way we can do that is that there's a tool called Buffer. And what Buffer does, it's like an offset in AutoCAD, where it basically just takes the outline of each shape and then it offsets it by a given distance. So we can find that by clicking on the Analysis tab. Here, I'm going to close my ideal habitat. I'm going to close all these tables down at the bottom here. I'll click on this Analysis tab. And then I want to click on Tools. And over on the right side, that's going to open up my geoprocessing window. And I want to search for the tool called Buffer. It's actually, I don't even have to search. It's the second one down under Favorites. If you don't see it there, you can just type in Buffer and it'll come up. Right, so Buffer is just going to create, like I said, an offset for each one of these patches by whatever distance we tell it to. So our input feature is going to be ideal habitat. And the easiest way to tell it that we're using that is to just grab ideal habitat from contents and drag it over here and drop it into input features. Output feature class, let's call it, instead of ideal habitat buffer, I'm going to call it effective habitat. Again, no spaces are allowed.
Hey, Scott, I gotta go.
Okay.
When are you expecting us to turn this in just at the end of today?
Actually, we can finish. Yeah, I guess class is done. So let's finish this up. I'll finish this up in class on Tuesday, and then this will be due at the end of class on Tuesday. So I would urge anyone who fell behind today, get caught up to the point that we're at. And then on Tuesday, we can kind of finish going through this and making sure that we have everything finished.
All right. Thanks, Scott.
Yep. And I'll post this recording as soon as it's done processing in Zoom. So that should be up in a few hours. All right. Have a good one, everyone. I'll see you guys on Tuesday.
Thank you.
Yep.
Got.
Yes.
So I'll retry. I was trying to do this whole thing on my roommate's computer because last semester for GIS I had to do it, or I didn't have a computer to do it of my own.
Okay.
So I just got it downloaded onto my computer. So I'll retry this assignment, but I don't know what was going on before.
Okay. Yeah, give it another try. Unfortunately, I have like back-to-back meetings until 1 o'clock. But just shoot me an email if you have any, if you're still having issues, and then we can set up a Zoom time when we can meet and try to figure out what's going on.
Okay. It's just frustrating because I've taken GIS. And, I feel like I know how to do it, and it's still.
Yeah. Sometimes weird stuff happens.
Yeah.
Okay. Good luck with that.
Thank you. When are you gonna post that Zoom?
As soon as it's so it takes it like a couple of hours for it to like process the recording and then upload it to YouTube. So sometime this afternoon it will be posted.
Okay. Thank you.
Yep.
Have a good day.
You too.